In the world of aerospace engineering, failure isn't just expected. It's embraced as a path to innovation, and no company embodies this philosophy more than SpaceX. While most aerospace companies would take months to recover from a failed launch, SpaceX is already preparing for Starship Flight 9, just days after the dramatic Flight 8 failure. This unrelenting drive is exactly why Starship, despite being the largest and most complex rocket ever built, continues its rapid development cycle. The contrast couldn't be more striking. Flight 8 just ended with a catastrophic explosion in the upper stage, yet SpaceX engineers are already implementing crucial fixes for the next launch. According to Elon Musk, Flight 9 could launch as soon as mid-April 2025, just 4 to 6 weeks from now. What makes this upcoming test so critical is that Flight 9 represents a potential turning point after 2 consecutive failures. While Flight 6 had achieved the historic milestone of catching the Super Heavy booster with Methuselah and successfully testing the upper stage through to splashdown, Flight 7 and 8 both ended in spectacular failures. Now, with Booster 11 and Ship 30 already undergoing rigorous testing, SpaceX is focusing on 3 critical improvements: enhanced Raptor engine reliability, upgraded attitude control systems, and reinforced heat shield attachments. The stakes couldn't be higher. If successful, Flight 9 could surpass even the achievements of Flight 6 and potentially demonstrate satellite deployment capabilities, a crucial step towards Starship's planned role in expanding the Starlink constellation. To understand why Flight 9 is so crucial, we need to look at Starship's development journey, a roller coaster of spectacular failures and breakthrough successes. Flight 8 began with promise. The countdown proceeded flawlessly as SpaceX loaded Starship and its Super Heavy booster with supercooled liquid methane and liquid oxygen. All 33 Raptor engines ignited with perfect precision, generating an earth-shaking roar as a massive rocket lifted off. For those first moments, it seemed SpaceX might finally achieve another successful mission. The Super Heavy booster executed its role perfectly, powering through the lower atmosphere before the hot staging maneuver separated it from the upper stage. Then came what should have been the headline achievement. The booster successfully executed its controlled descent and was caught by Methuselah, the massive launch tower arms. This marked only the second time in history that SpaceX had successfully caught the world's largest rocket booster. But the celebration at Mission Control was short-lived. Just as engineers were congratulating each other on the booster catch, disaster struck in the upper stage. An unexpected energetic event. Engineering speak for an explosion occurred in the A section of Starship. This catastrophic failure cascaded quickly, causing multiple Raptor engines to shut down almost simultaneously. With several engines suddenly offline, Starship lost its ability to maintain stability. The vehicle began veering wildly off course, struggling to maintain its planned trajectory as SpaceX's control systems desperately tried to compensate. The situation deteriorated rapidly. Within moments, all communication with the vehicle was lost, and approximately 9.5 minutes after liftoff, Starship was completely destroyed. This marked a significant setback for SpaceX, especially considering the pattern of recent flights. Starship's development has followed a fascinating trajectory. The first test flights, 1 and 2, were explosive failures but provided invaluable data on structure, integrity, and basic flight systems. Like the early days of Falcon 9, these failures were expected stepping stones. Flight 3 showed improvement, getting much further in its ascent before encountering issues with the hot staging process. Flight 4 successfully completed that critical hot staging maneuver but still failed during re-entry. The real breakthrough came with Flight 5, when for the first time, the Super Heavy booster executed a controlled soft landing attempt in the Gulf of Mexico, while the upper stage survived long enough to transmit crucial data about its re-entry profile. This was a major validation of SpaceX's design philosophy, but the true crown jewel was Flight 6, SpaceX's most successful Starship test to date. In a historic achievement, the Super Heavy booster not only returned to the launch site, but was caught by Methuselah's massive arms. Meanwhile, the upper stage completed its entire mission profile: successful ascent, space coast, atmospheric re-entry, and controlled splashdown in the Indian Ocean. After such remarkable progress, nobody expected what happened next. Flight 7 represented a shocking regression. The booster lost control before it could reach the tower and crash into the ocean, and the upper stage suffered catastrophic structural failure and exploded before even reaching the re-entry phase. Then came Flight 8, which, despite successfully catching the booster, experienced an even earlier and more dramatic failure of the upper stage. So what's different about Flight 9? According to sources inside SpaceX, everything. Booster 11 and Ship 30, the vehicles designated for Flight 9, incorporate significant design changes based on failure analyses from the previous missions. Engineers have identified 3 critical areas requiring immediate attention. First, the Raptor engine reliability issues. The simultaneous failure of multiple engines during Flight 8 revealed potential weaknesses in the engine design or their integration systems. Both Booster 11 and Ship 30 have already undergone extensive static fire tests to verify these improvements. Engineers have reinforced propellant lines, redesigned critical seals, and updated ignition sequences to prevent cascading failures. Second, Starship's attitude control system has been completely overhauled. The flight software now includes enhanced redundancy protocols that can compensate for multiple engine failures without losing vehicle stability. This represents a significant advancement over previous versions that couldn't handle the sudden loss of thrust experienced during Flight 8. Third, the heat shield attachment system has been fundamentally redesigned. Previous flights showed tiles detaching during the extreme aerodynamic forces of ascent and re-entry. The new attachment mechanism uses a more robust mechanical connection rather than relying primarily on adhesives, with each tile now capable of withstanding temperatures exceeding 1,400 degrees Celsius. Beyond these technical improvements, Flight 9 will attempt something never before achieved, a full demonstration of Starship's payload deployment capabilities. This is crucial for SpaceX's future plans to use Starship as a mass deployment vehicle for Starlink satellites. The payload bay doors, a system never fully tested in previous flights, will open in the vacuum of space to simulate releasing a cluster of satellites. While no actual satellites will be deployed on this test, the mechanism must function perfectly for future commercial missions. The success or failure of Flight 9 carries enormous implications. After 2 consecutive failures, SpaceX needs to win not just for morale but for practical business reasons. NASA is closely watching these tests, as Starship has been selected as a human landing system for the Artemis program. Continued failures could potentially delay America's return to the lunar surface. Furthermore, SpaceX's ambitious plans to send humans to Mars depend entirely on Starship's success. Elon Musk has repeatedly stated that making life multiplanetary requires a fully reusable spacecraft capable of carrying large payloads, exactly what Starship is designed to be. Internal sources suggest that a successful Flight 9 would immediately be followed by Flight 10, potentially within weeks rather than months, accelerating the development timeline dramatically. This rapid iteration is a cornerstone of SpaceX's approach to spacecraft development. Fly, fail, fix, and fly again. As we count down the weeks to mid-April 2025, all eyes in the aerospace industry are fixed on SpaceX's starbase in Texas. Flight 9 represents more than just another test. It's a critical inflection point in humanity's journey to becoming a multiplanetary species. The pattern of Starship development tells us something profound about innovation itself. Progress isn't linear. It's a series of breakthroughs followed by setbacks that ultimately lead to great achievements. Flight 6 success, followed by the failures of Flight 7 and 8, isn't a regression. It's a natural rhythm of pushing technological boundaries. What makes SpaceX different is their refusal to slow down. While other companies might take months to analyze failures, SpaceX's rapid iteration philosophy means they're already implementing solutions and moving forward. This relentless pace is why Starship, despite its enormous complexity, continues to advance at unprecedented speed. If Flight 9 succeeds, we won't just witness another rocket test. We'll be watching the moment when reliable, fully reusable super heavy lift capability becomes a reality. That's the difference between occasional visits to space and becoming a truly spacefaring civilization. What do you think will happen with Flight 9? Will SpaceX finally achieve another successful mission, or are more challenges ahead?